Hey, John here. Let's talk about this character data type. What does it mean? What are the values that it can have, and how is it used in different contexts? All right. This goes back to, 40, 50 years ago when they invented the C language, and they created a file called ctype.h. And when the C++ guys came around and said, well, we don't like the H's on the ends of our files, I honestly don't know why. They wasted their time bickering about it, but they decided that they would instead put the letter C followed by the name of the include file from the C language without the .h to include them like this. Feel free to throw in comments as to why this was such a big deal to them. I don't know. In any event, the cctype include file or the ctype.h, if you prefer, you can put either one in here. It'll work either way. Defines a number of things that you can use, a number of routines that you can use to inspect the types of characters and stuff. We'll talk about that in a minute. So let's start with something very simple. Let's say I got a character variable. I'm going to call it ch. I'm going to assign it a value b in single quotes. Means I'm going to use a single character literal value. Okay, and that B is the code for the letter B, all right? Otherwise, you'd have to look it up, and it's probably like a 66 or something like that in decimal. It's easier to just, put it in there like this. Like I said, I can't even remember what it is, but it's around 60-something. Anyway, I then come along and I say ch equals, I'm going to print out the character. Hopefully, we'll see a B in there. Then I'm going to cast it to an integer and print it out again. What, as the comment up here suggests, is that this insertion operator will, if given a single character variable, which is what ch is, or more accurately, a variable whose size is 8 bits, or size of ch equals 1, as we'll see when this thing runs. If it's the size of 1 byte, it will print out the value that the code represents, like a B. If I cast it to an int, what I'm doing is I'm asking the compiler to convert this 1 byte character variable to a 4 byte integer variable, at least on the platform that we're using, which is Linux on a PC. And then the insertion operator will treat it as a decimal number and print out the numeric value. So this single line of code here is going to say ch equals, and it'll print the code, it'll print the character that the variable has in it, which will be a B. It'll then say ch equals, some number, which is the code number for that letter. The size of should be 1 byte. So let's go ahead and compile this program. Looks like I already compiled it. Let's run it. And sure enough, here we are, 66, okay, is the code of a B, capital B in particular. So let's go ahead and change it to a C and see what happens here. Run it again. Now we notice it went up to a 67. What do you suppose the code number for a D is? I hope you guessed right, and it would be a 68. If you don't know, you can type man ASCII. C and C++ programs are written and encoded according to the spec in the ASCII character set. On a Unix system, you can type man ASCII. What you're doing here is you're asking to see the manual page for the word ASCII. And there's a nice table in here, and it says, oh, by the way, these are all the code numbers for ASCII characters. And as you look over here at the B, you can see in decimal, it's 66. In hex, that would be a 42. In octal, it would be a 102. All right, so they give you all these different variations in case, you want to know whatever the values are in different number bases. So again, when we changed it to a C, that's what we saw, the 67. If you look around in here, you see all these other weird things. You probably don't even know what those are. There are codes for control sequences. These go way back in time to like teletypes and Western Union and all this sort of thing when they're sending messages. There's a bell that would ring on the screen and so on. There's a backspace, horizontal tab, that's your tab key on your carriage return. Line feed is when you hit the enter key, so to speak, on your Unix machine. Vertical tab is like I don't know what the heck that is. I've never used it myself. Form feed is when you're on a paper terminal, it goes to the top of the next page, or your printer will move to the next sheet or whatever. The carriage return moves you from anywhere in a line back over to the left. but it does not go down a line. So usually, if if you're printing something out on the screen and you're at the end of a line, you want it to go back over to the left and then down a line. And that gets into all kinds of crazy stuff on different systems. Sometimes, like Unix systems, the new line alone will take you down a line and over to the left. Other systems, not so much. So that's a Windows thing, is a little different than Unix. And I think even the Mac does something different as well, although maybe not anymore, because once they moved on to OS X, they threw away all their old stuff, and that's just Unix running under the hood of that thing anyway. So these days, I suspect OS X and Linux are the same thing, and Windows is still off doing their own thing with a whole weird stuff going on. Anyway, you can see all the usual characters from your keyboard in here. Now, remember, ASCII stands for the American Standard Code. What is it? American Standard Code for Information Interchange. All right. So, yeah, we didn't bother to pay attention to any other languages. If you wanted to put, Cyrillic symbols in there and kanji and stuff like that, you have to use Unicode and other kinds of character types, which cause all kinds of interesting problems when you're mixing languages in the same program, especially want to sort something alphabetically. What does it mean to have two different languages in there? We're going to stay focused on just ASCII to keep it simple, okay? But as you move on to the international codes, all the same stuff applies, but it's just more of the same. All right, so if we edit this file, what are we doing here? Again, the big takeaway here is that the insertion operator, if it prints a 1-byte value, it's going to print the character glyph that looks like a C. If we print it as this way. If you convert it to an integer using a cast of some kind, it'll print the integer numeric value that's stored in this variable that represents the C, okay? And that's exactly what we just saw. So it said C, and then we saw the 67, and we know the size of a character is 1 byte, okay? All right, so here's our same thing we just saw a minute ago without the integer involved in there. Let's look and see what some of these other things are. Now, these come from the thing I mentioned earlier, this cctype thing, all right? This include file, sometimes called a header file, which is what the H stands for in the naming convention. So that header file includes declarations for all these library functions, all right? Is alphanumeric? Is alpha? Is it control? Is it a digit? Is it a graphic symbol? Will it print something on the sheet, right? Is it lowercase? Is it printable? I don't know what the difference between printable and graphic means, but you can look it up by reading the man page for these respective functions. The point is they have these character classification functions available so that you don't have to memorize all these numeric values, okay? So if we create a character and put an A in it like this, print it out, ask for the size of the thing, we can also use some other ones that come from ctype, like to lower and to upper. Down here, I call this what is function, which is what we were just looking at up here, all right? So what is this thing going to do? It's going to print out the character, and it's going to say, if I send it to lower, what happens? If I send it to upper, what happens? And so on. Obviously, CH is an uppercase letter. So if you say to lower and you give it a single character that's an uppercase character code, it'll convert it to a lowercase code, and then it would print it out. So that's what we're going to do here. We're going to see this thing work. If it's already uppercase and you say translate it to upper, it will effectively do nothing and give you back the uppercase character. So let's go ahead and compile this up. I guess it's already compiled. And run this thing and see what happens. All right, so we got what? A, size of A is a 1. Now look at what's going on with these uppers and lowers. Let's ignore all this for a minute. All this is screwy, right? What the heck is all these numbers, right? So let's understand something here. First of all, we printed out character is the CH variable, and it printed as an A. We did the size of. We just saw that in the ctypes 1. All right, in ctypes 2, we did the same thing. Okay, then we print out the character again, and then we call to lower, and we want to convert it to a lowercase a. And we got 97. Well, let's look at something here. If we look up what a 97 is, we can see 97 is a lowercase a. Well, remember what I said about the insertion operator. If you ever give the insertion operator an integer, it's going to print the numeric value. This is printing the number, not the character glyph, which would be the lowercase a, right? So what insights does that give you about this function? This function, if we read the manual page for it, returns an integer. That's what it means. To upper returns an int. And it comes from ctype.h. And I already explained that in C++ you can put C followed by the name of the header file like that, which is what we did in our source code. So if we look at to upper and to lower, read the documentation. If it's an uppercase letter, lower will return the lowercase. If the lowercase representation exists in the current locale, all right, now that has to do with the internet, these international alphabets and stuff like that. As we add support for other languages. So this is already working its way into the documentation. Granted, it's been going on for 30 years, but it's going along very slowly. It says otherwise it returns C, because that means it's already, say, for example, lowercase, right? But the whole point of looking in here, other than showing you how to read a man page, is that to notice that this does, in fact, return an int. It does the opposite thing that we saw happen in... We forced it by hand in the ctypes 1 example program. So we can do the opposite in this case. Now, there's two ways to do this. As you saw, you can use a static cast, which is very C++, like this, which will take the integer value in these parentheses over here and converted it to a single character. Now, it might screw it up in the process, so you can't just do this any old time. But in this case, I happen to know it's okay. We already saw that it's a 67 or 97 or whatever it was. The other way to do a cast is like this. This, where you put character, put the data type in parentheses in front of the thing, this is a C-style cast down here, all right? I think I mentioned this before. Static cast up here. This is the C++ way of doing it. Now, you can do it either way. You'll get the same results. The latter is considered more old school. If we run it again now, look what happens. Now we get the letters instead of these numbers, simply because the data type itself changed. Notice the value did not change. A 97 in decimal is the code of a capital A. A 65 is the code in decimal of a lowercase a. So these are two different facades of the same thing. Did I say that backwards? Upper is 65, lower is 97. You can follow along. I think if I misspoke here, get over it. I'm not going to re-edit this darn video. Anyway, so to convert the thing to a lowercase letter, you can use these functions here. What you do with it after you've converted it is up to you. And by just simply sending it to the insertion operator and shoving it over to cout can be a problem because it's going to look like an integer unless you cast it here. Another way out of this, by the way, just for fun, xxx equals to upper of ch. If you assign it to a variable of type char, then it has no option, it has no choice. This is another way to convert it to a character. It's a little more verbose. We have a whole nother line of code in our program now, but this will do the same thing. Sometimes you might even get a compiler warning when you're if you define a new variable that is the wrong size, quite literally. This is called a narrowing coercion here. We're coercing an integer to become a character by assigning it like this. And by taking a 4-byte value and shoving it into a 1-byte hole, so to speak, we're narrowing its size. And sometimes the compiler can give you a warning or a complaint when you do this. If that happens, you then still have to go over here and then cast it either in C style or C++ style, all right? Anyway, my point is that depending on the type of the variable, the insertion operator may treat it a little bit differently, either as an integer or a printable character glyph. Okay, that's the whole takeaway there. Now let's see what comes out of this what is function. Why that? Well, 8, 10, 24. What is all this stuff? Well, the first thing you should notice is that these are all powers of 2. Okay, that should give you some insight as to how these is routines are implemented. I'll leave it as a task to the viewer to type in less user include, which is where all the header files are, ctype.h, and look through here and find out how all this stuff works. Okay, so these are, you just saw them all go by. Here's all the is type, is lower, and these are macros that call some other things and blah 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 blah. You can see in here how things are actually done if you want, because all the sources sitting right there for you to peruse. The bottom line is the way this is implemented is it uses a lookup table and some binary operators and things like that to give you these weird numbers. Now, it doesn't matter what the numbers are, so they chose a way that was efficient to implement it. All we care about is when we call these functions, we kind of want to think of this as a Boolean return value. Is control. Is this a control character? Well, obviously the answer to that is no. Is it a digit? No. Is it graphic? The answer is yes. Is it a lowercase letter? No. Is it printable? Yes. Is it punctuation? No. Is it space? No. Is it an uppercase letter? Yes. Is it a hex digit? Yes, because hex digits are 0 through 9 and A through F, both upper and lowercase A through F, right? So it turns out, once again, we see that 0 is false, and anything that's not 0 is true. Okay? So be careful how you what your expectations are when you call a library function that you yourself did not write. Okay? So if you just treat it as a numeric value, like the insertion operator does, because I just stuck it right in here. I said ch equals single quote, and I printed out the variable. It's a 1-byte variable, so it prints out as a character. I then print out the value that comes back from is lnum, which is another one of those things that's declared as an int. It returns an int. They could have made it return a character, but they didn't. They didn't consult us, so I guess we lose. So if you really wanted these to show up as Booleans, you could cast them as bool, all right? And then you'd get a 0 and a 1, probably. I assume that's the case. Let's go ahead and find out. Bool. We know that it is alphanumeric, and I'm sure it returned a weird number like 8. So let's go ahead and compile this. We should now see like a 1 or a 0. See what change the 8 to a 1. Right? Because once you cast it to a Boolean, it can only be a 0 or a 1. So the compiler did the right thing. And then when cout, it was given the insertion operator and sent to cout, it prints it out as a 1 or a 0. All right, so again, that's sort of like declaring an int versus a character in order to see the character versus the numeric code of the character. These things, because they return integer values, that's either 0 or non-zero. If you really want 0 and 1, you have to do the appropriate casting or converting yourself. All right, so these things here are these character classification functions that are very handy if you really want to know, you enter in like, do you want to continue and say yes or no, although I never do that in my programs. If you did, and you wanted to be able to deal with responding to both an uppercase or a lowercase letter, okay, what you could do is you could just call whatever it is to upper like this, right? So you could say something like, rather than writing if, maybe like answer, maybe you say something like this, cin, right arrow, ans. Now this is terrible practice and very annoying. To ask somebody if they want to continue usually we don't do that once we've finished the first semester of writing code, because if they didn't want to continue, they'd kill the program. Oops, if answer equals, like, let's say you did something like this, it'd be kind of naive, right? Because, and then maybe we'd say cout, thank you. Otherwise, we won't say anything at all. All right, so what does this thing do? It's going to read a single character from cin, and then we're going to ask if was it a Y, and if it was a Y, we'll say thank you. Otherwise, we won't do anything at all. Then we'll continue on to run this what is code down here, and I didn't do it right. Oh, because I didn't include it up here. All right, so it's waiting for me to hit Y or N. So I said little y. All right, let's run it again. If I put a capital Y, you'll notice it didn't notice it, right? Because we only compared it to the little y like we did up here. So one of the things you can do is ask is here to lower that equals to Y. All right, now we don't have to worry about asking if it's uppercase or lowercase and all this other stuff. We know that no matter what it is, if I type a capital Y right now, it's still going to work because we converted it to lowercase. Then we compared it to the lowercase character down here. All right. Now, I personally don't like it when people ask, do you want to continue? Because if I didn't want to continue, I would kill the program. There are times when you need to do that, but more often than not, if you're writing what's called a filter program, you don't want to pause all the time. You just spew all the output. If the user really wants to paginate through their output or something, there are other ways to do it that are much more convenient than putting in this yes/no stuff all over the place in your program. Okay, so what's the takeaway here? There are these character classification macros that we can ask about various data types. Let's go ahead and just change this to like a 7 and just run it once more, just to drive that point home with a massive sledgehammer. So before we were asked about this A, and we could see its graphic. Is it lowercase? Is it printable? Is it uppercase? Is it a hex digit? Yes. Is it alpha? Yes, and so on, right? Up here, we have a 7, so it's no longer alpha. It's not control. Is it a digit? Yes. Up here, it was not a digit, right? No, and so on. All right, so that's what these things are useful for, as you run yourself into a situation where you need to check to see what's going on with a single character. Thanks for watching. See you next time.